So section 6.4, assessing normality. So the distributions you have seen up to this point have been assumed to be normally distributed. Okay. But how do you determine if that's a reasonable assumption to make or not? Okay, so one way is to take a sample and look at the sample to determine if it's reasonable to assume that that sample data came from a normal population. So again, we're kind of heading into inferences here. So we're taking what we saw in the sample data to try to draw an inference about the larger group or the entire population. So how do we do that? So here are some guidelines that are used to help make this determination. So the first thing is to make a histogram. And for a normal distribution, the histogram should be roughly bell-shaped. Now remember, a histogram is actually a bunch of rectangles, and so by bell-shaped, we've got these rectangles that kind of stair-step up and stair-step back down. So we've kind of got this unimodal and symmetric distribution going on. For small samples, though, this is not very accurate, and another method is needed. Okay, the histogram of the sample data may not look normally distributed, but the sample still may have come from a normally distributed population. But for a small sample, we just didn't get enough representatives from that population to see that happening in the histogram for that sample data. The second thing that we need to do is we need to check for outliers. So for a normal distribution, there shouldn't be any outliers. So one way to check for outliers is to use a modified box plot. So these are two graphs that we actually learned how to make back in Chapter 3 for quantitative data. And so on the modified box plot, the outliers are the values that are shown as dots outside the rest of the values. The new plot that we get in this chapter is something called a normal probability plot or a normal quantile plot. And this plot is provided through statistical software on a computer or a graphing calculator. And this particular plot is designed such that if the points lie close to a line, the data come from a distribution that's approximately normal. If the points do not lie close to a line, or they show a pattern that's not linear, the sample data are likely to come from a population distribution that's not normally distributed.